Welcome to the lesson. Well, in this video, we'll be covering physics, that's Physical Sciences Paper 1 for grade 12 learners. Well, by the end of this lesson, you should be able to understand and solve momentum problems. I expect you guys to also have an understanding of impulse, and you should be able to express Newton's second law in terms of momentum. It is also required of you guys to understand the law of conservation of linear momentum and also have an understanding of change in momentum. Well, let's get on to it. Before I can get on with grade 12 work, let's start with previous knowledge from grade 11. What I expect you guys to know from your previous grade. Well, you need to know and define scalar quantities. Well, these are quantities with magnitude only. We only have magnitude for these quantities. For example, we have mass and energy. And then the second quantity that you need to know, vector. Well, for this quantity, we have both magnitude and direction. Both magnitude and direction for vector quantities. For example, we have velocity, where we have both magnitude and direction. And the third quantity that you need to know is your mass, which is the quantity of matter in a body. That's your mass, quantity of matter. You need to be familiar with this concept. And then the next quantity that you need to know is your velocity, which is the rate of change in displacement. You need to be familiar with this concept right here. And then the following or the next concept is acceleration. You need to have an understanding of this from grade 11. And this is your rate of change in velocity. That's your acceleration. And then I also expect you guys to have knowledge of Newton's laws. That's your Newton's second law, Newton's third law, and so on. You need to be familiar with these laws. Well, the Newton's second law, that's where you have force equals to mass times acceleration. You need to be familiar with this concept right here. And then the next one, you need to know the Newton's third law. Well, now this one states that when object A exerts a force on object B, object B simultaneously exerts the same force but in the opposite direction. And the last concept that I expect you guys to know from grade 11 is the law of conservation of energy. Law of conservation of energy. Well, this law states that the total energy of an isolated system remains constant, like it doesn't change. You need to be familiar with this concept for you to have a better understanding of momentum and should be able to solve different problems involving momentum. Let's get on right into it. Let's start with grade 12 content with the first topic, which is momentum. You're going to need to apply the previous knowledge for you to have a better understanding of this topic, momentum. Well, now this is a vector quantity and it has the same direction as the velocity of the object. So for example, let's say you're given an object moving in the east direction. That object or the moment of that object will be having the same direction as the velocity of the object. You need to be you need to be aware of that. It's a vector quantity. And it's given by the formula mass times velocity. That's your momentum right there. And then from here, this mass or this m is your mass in kilograms, and then this v here is your velocity in meters per second. And then from here you can see that momentum is a product of your mass and velocity. It's a product of mass and velocity. That's your momentum. And if momentum is a product of mass and velocity, that means momentum is measured in kilograms meters per second. That's the SI unit of momentum. And then from the same equation there, you can see that momentum is directly proportional to your mass or the mass of the object. Well, this means that as the mass changes or as the mass increases, the momentum is also going to increase. And then we can show this graphically by just drawing this sort of diagram here or sort of graph where we have momentum on the y-axis and then mass on the x-axis. And this means that as momentum or as mass increases, momentum also increases. So we're going to have a straight line relationship between the two quantities there. And then from the same equation, you can see that momentum is directly proportional to your velocity. Well, now this means that as your velocity increases, the momentum of the object is also going to increase. So we're going to have a graphical representation there where you have velocity on the x-axis and then momentum on the y-axis. So now it's also going to be a straight line relationship between momentum and velocity. This is showing that as your momentum or as your velocity increases, momentum is also going to increase. And then let's do a simple example just to help you understand this concept of momentum and how you can use this equation given here on the left. Well, the first example, you're given a car or a vehicle with a mass of 1,050 kilograms. That's the mass of the vehicle that you're given here. And then it's traveling east at a speed of 60 kilometers per hour. 60 kilometers per hour in the east direction. So you need to calculate momentum. Momentum of this vehicle. So now we know that momentum is given by mass multiplied by velocity. And in this case, we're given the mass and the velocity. Well, you need to take note that our velocity is given in kilometers per hour. So let's change it to our SI unit, which is meters per second. So it's going to be velocity equals to 60, and then you're converting your kilometers to meters. You multiply by 1,000, and then you convert your hour to seconds. That means you're going to multiply by 3,600 seconds. And then from there, you're going to get 60 multiplied by 1,000 divided by 3,600. So now we're going to have 16.67 meters per second. That's our velocity in meters per second. 16.67. So now go back to our equation. Momentum equals to, the mass given as 1,050 kilograms multiplied by the velocity, which is 16.67 meters per second. And then from that, you're going to get 16.67 multiplied by 1,050. Well, that's 17503.5 kilograms meters per second. That's your momentum for this object. And you need to remember that momentum is a vector quantity. That means you need to add your direction for this final answer. You need to add the direction of this momentum. So as I said, this momentum takes the direction of the velocity. So it's going to be this in the direction, in the east direction. That's where you're going to have your final answer. And then let's move on to impulse. That's the second concept that you're going to be talking about in this lesson. You need to move on to impulse. Well, there's a relationship between impulse and force. That's what you need to understand. And I'm going to give it to you right now in a moment. Let me just erase again on the left to make more space for the second concept here. And then just take it from there. Now we're working with impulse. Well, now impulse is a product of the net force of the object and time. So that's product of net force, F net, and time, or change in time of the object. So now, in this case, let me just write it properly here. Impulse, a proper equation for you guys to remember, equals to F net multiplied by time. That's your impulse. And then you know that force is measured in newtons, and then time, the SI unit, is seconds. And then let's move on now to the Newton's second law, expressing Newton's second law in terms of momentum. So now we know that Newton's second law states that when a force is applied to an object will move in the direction of the force. And then we know that the acceleration is directly proportional to the force applied. And yeah, while expressing this law in terms of momentum, we're going to have F net equals to change in momentum divided by change in time. Because now it states that the net force acting on an object is equals to the object's rate of change of momentum. So this net force, in this case, is equals to the rate of change of momentum. Unlike in the second law, where it says F net equals to mass times acceleration. So in terms of momentum, it's going to be this in this form now. And then from this, we know that momentum is measured in kilograms meters per second, and then as a unit of time, seconds. So you need to always remember that the SI units, because they're very important when expressing different quantities. And then now let's move on to the next concept, the law of conservation of momentum, which I've already stated that it states that the total momentum or the total energy of an isolated system remains constant or is conserved. And then the last concept that I'm going to look at before we can do any examples is the concept of change of momentum. Change of momentum, that's the last one that we're going to be looking at before we can do examples and apply this concept to different problems. Well, now momentum changes when the object's velocity changes, because as you know, momentum is directly proportional to the velocity. So if the velocity changes, the momentum is also going to change. And then for this concept, we assume that momentum, the mass remains the same during the collision, assuming that the object doesn't break. So that means our mass is going to be the same. The only change that we're going to have is the velocity. We're going to have a change in velocity, and this is also going to affect our momentum. That's why we're going to have a change in momentum. Let me just write an equation here to show you how we're going to apply this. Final change in momentum is equal to final momentum minus initial momentum. And then we're going to have mass times velocity, final minus mass times velocity initial. So this is just your final momentum, that's your initial momentum. And then from here, you can take the common factor, which is your mass, assuming that the mass doesn't change. So final velocity minus initial velocity. That's our change in momentum. And then you also need to remember the SI units for all these quantities here. And from there, I want us to apply these concepts and this equation that you just learned about in the following problems that I'm going to be working on here. Well, the first one, you guys can pause this video and write down these equations, and then you can apply them in the following problems. Well, the first one, or the first problem that you're going to be dealing with, we have a car with a momentum of 20,000 kilograms meters per second. And then this car, well, in this example, we're given that what is the car's new momentum if its mass is doubled. So if we double the mass, what's going to be the car's new momentum? So we're doubling the mass. And remember that momentum is directly proportional to the mass. So that means if we increase the mass, the momentum is also going to increase. And in this case, we're doubling the mass. That means we're also doubling the momentum. So we're going to apply that. We're going to do that quickly now. Okay. And they're telling us that the car is traveling at the same velocity. So velocity is constant in this case. Velocity is constant. The only change that we're having is the change in mass. So now we know that momentum equals to mass times velocity. And then from that, we can just multiply this by 2 to get this new momentum. Let's just give it a suffix there. That's your initial momentum, and then that's your final momentum. So now, like I said, if the mass is doubled, that means the momentum is also doubled. So we just have to multiply this 20,000 by 2. It's going to be 2 multiplied by 20,000 kilograms meter per second. And in this case, we're going to have 40,000 kilograms meter per second. This is our new momentum, and it's going to be in the same direction as the velocity. In the same direction as velocity. You need to always remember to put your direction there when you're working with vector quantities. And in the second example, let's look. Well, you can just check on the screen there. You have a display of these examples that we're working on here, and you can just pause the video and try to write those questions down. So now with the second one, it says what will be the velocity if the momentum is given as this. If the momentum is 60,000 kilograms meter per second, and then the mass is 2,000 kilograms. So now they want us to find the velocity. We're given the momentum and also given the mass. So we need to go back to your equation, which says momentum equals to mass times velocity. And then from that equation, you need to make velocity. Well, let me just write it here. We're looking for velocity. You need to make it the subject of the formula. So it's going to be velocity equals to momentum divided by mass. And then from there, we're going to have the momentum, which is 60,000 kilograms meter per second, divided by the 2,000 kilograms, which is our mass. Let's just do that quickly. We're going to get, that's 30 meters per second, in the same direction as the momentum. You need to remember that velocity is also a vector quantity, so it's in the same direction as the momentum that's given there, as momentum. And then now let's move on to our last example that we're going to work on here. This one is a bit long, so let me just make some more space for this example. We just do it on this side. Okay. Well, in this example, we're given that a truck has a mass, third example, a truck has a mass of 6,000 kilograms. And then it's traveling at 80 kilometers per hour. That's our velocity. And then they're saying, how does the momentum change if the truck is loaded with 1,200 kilograms? So that means we're increasing the mass of the truck by 1,200 kilograms. And then it's traveling, well, it's going to travel at 60 kilometers per hour. So now this is going to be our final velocity. This is the initial velocity. This is the final velocity. So after loading the truck with an object of mass of 1,200 kilograms, the truck's velocity is going to change, or the truck is going to slow down to a velocity of 60 kilometers per hour. So now you can see that these velocities are given in kilometers per hour, and we know that the SI unit of velocity is meters per second. So the first thing that we need to do, we need to convert these velocities to meters per second. So starting with the initial velocity, let me just write it on this side here to save space. Okay, we're gonna have 80 multiplied by 1,000, that's converting it to meters, and then divided by 1 multiplied by 3,600 seconds. And then we're gonna have something like, that's 22.22 meters per second. That's our first velocity, or that's our initial velocity. And after loading the truck, we're gonna have a velocity of 60 multiplied by 1000 divided by 1 multiplied by 3600. So now we're converting it to meters per second, which is our SI unit for velocity. And that's going to give us 16.67 meters per second. So we've converted our velocities now to the SI unit. So now let's find the first momentum, or the momentum before loading this truck with a certain object. So now it's going to be mass initial, velocity initial. And that's going to be, the first mass is 6,000 before loading this truck. We have 6,000. 6,000 multiplied by the velocity, which is 22.22. So you need to remember that you need to use your velocity, or the converted velocity, which is in your SI unit. You can be using this 80 kilometers per hour because that's not the SI unit for velocity. You need to remember that. That's very important. Okay, so now we're gonna get this huge number now. 1333. What? But it's, yeah, that's your momentum now. The first one before loading this thing with that object of mass of 1,200 kilograms. So that's the first momentum that we have. And then after that, after loading this truck, we're going to have the final momentum. Well, with the final momentum, mass final multiplied by velocity final. So for the final mass, you need to remember that the truck has a mass of 6,000, and then we're adding an object with a mass of 1,200 times to the truck. So that means now our final mass will be 6,000 plus the 1,200. That's our final mass now. The mass is going to change. And then multiplied by the new velocity after loading the truck, which is 16.67 meters per second. 16.67. That's our new velocity. And now from that, we're going to get 7,200. This two. That's 7,200. Multiplied by 16.67 meters per second. And we're going to get 1,200,24 kilograms meter per second. That's our final momentum. And then for changing momentum, we know that it's equals to, let me just squeeze it in nicely here. Changing momentum, it's our final momentum minus initial momentum. And we know that our final momentum is this right here, 1,200. Oh, no, sorry, I made a mistake. It's 1, 2, and then 2 zeros, and then, yeah, it goes on like that. It's not 1,200. And then minus the one at the top there. That's our initial momentum. Let me just make space for this because I feel like it's a bit messed up here. It's a bit difficult for you guys to see. Let me make space on the left so that you guys can see it properly here. Because now that's our final answer. Let me just quickly make space for this here. Okay, yeah, it's our third example. And then change in momentum equals to final momentum minus initial momentum. Well, the final momentum is 1,200,24 minus 1,3,320. Oh, I missed the 3. Then 20. And then we're going to get 1,3,296 kilograms meters per second. So now that's our change in momentum. It's going to be a negative now. And it just shows, this negative shows that it's in the opposite direction. You need to remember that. And yeah, that's our final answer. And that's it for this lesson, guys. Join me in the next lesson. Thank you very much.